Our next unit is on scale diagrams and then on similar triangles and similar shapes. So the first part is scale diagrams. And with scale diagrams, sometimes you make something bigger, sometimes you make something smaller. When you make something bigger, it's called an enlargement. And if you do it by a constant factor, like that happy face looks like everything has been doubled, it's now twice as high, twice as wide, twice as happy. That would be called an enlargement. And how much you multiplied by would be called the scale factor. Next, if you make something smaller, we call that a reduction. So there's space for you to write this one in as well. A decrease in the dimensions of an object by a scale factor. Okay? So there's a grasshopper, and everything has been cut in half. So it looks exactly the same. It's just been reduced by a constant factor. And that constant factor is called the scale factor. That's how much each of your dimensions are increased or decreased by. So whenever your scale factor, if you turn to the next page, whenever your scale factor is bigger than 1, it is an enlargement. And whenever your scale factor is less than 1, it's a reduction. So we're going to look at this first example. Draw an enlargement of the following object with a scale factor of 2. So what we're going to do is we're going to measure all the distances from the center to each of the points. For example, from here to here, that distance is currently 3. Would you agree when you count that? And so if your scale factor is doubled, you would take that 3 and multiply it by your scale factor, and you would get 6. So my new point would get doubled out to there to be 6. What happens to this point? Same thing. It's 3. Now it's going to get doubled to 6. This one's 3, get doubled to 6. 3, get doubled to 6. And now it's the fun part of just connecting the dots. And this one has been enlarged by a scale factor of 2. We are going to do a reduction. I'm going to make this bigger so you can see it better. Again, if you count from here to here, this distance was 3. If we have a scale factor of 1/3, we're still going to be multiplying 3 times 1/3. And now this goes back to our first unit. How do we multiply fractions? First of all, what's 3 as a fraction? 3 over 1. For multiplying fractions, do we need a common denominator? No. No. What's the rule for multiplying fractions? Multiply tops, multiply the bottoms. 3 times 1, 3. 1 times 3, 3. Can you reduce that? No. 3 divided by 3 is 1. So our new length is only going to be 1. And the same thing in this direction, only 1, only 1, only 1. And there we have a reduction by a scale factor of 1/3. Again, I'm going to make this bigger we go. So it says, enlarge the following shapes by a scale factor of 3 and then reduce it by 1/2. So one of the things you might want to do in something like this is use a ruler. So I'm going to show you how you can use a ruler. Some of the points are really easy. For example, I'm going to say that this point is going to be really easy and this point is going to be really easy. Because if we count the distance from here to here, it's 2. And if you enlarge it by a factor of 3, 2 times 3 is 6. So I go 2, 4, 6, 2, 4, 6. So I did those 2 green points first. If this length here, have a look at this, guys. If this length here is 2, and I multiply that by 3, what is the length going to be over here? 6. So that would mean I'd have to go up 3. Oh, I want to do that in blue. Go up 3 and down 3. Another thing that you can notice, because everything starts from the center, I want you to notice that on the original one, you go down 1 over 2. That would be once. If you need a scale factor of 3, you would need to do that 3 times. So down 1 over 2 again, down 1 over 2 again. That'll get you to that point. Because we have to do it with a scale factor of 3 times. Okay? So a trickier point right now is going to be this one. Can you see, to get to that point, you have to go up 1 over 1/2. And if your scale factor is 3, you're going to need to do that 3 times. So here's 1 time. 2 times would get me there. 3 times would get me there. So I'm going to have this point here. Similarly, I would have this point down there. You can join those together. Okay, I'm going to do a little bit of erasing on here. Let's check out this point right there. Does it look like it goes up 1 3/4 and then over 1? Over 1/2, sorry. So we have to go up 1 3/4 over 1/2 and then up 1 3/4 over 1/2 again. Okay, so I could imagine this point being about there, doing that 3 times. But another thing that you can do with a ruler, okay, is you could take a ruler and take this point and measure this distance. So I've got a ruler here. I'm going to go up to Logan's here, and I'm going to measure. It looks like it is 0.9 millimeters, or 0.9 centimeters, 9 millimeters. If I multiply 9 millimeters by 3, I would get 27 millimeters. So now if I take my ruler, start from the center again, go through that same point, and measure 27 millimeters. So I line my ruler up to go through this point and measure 27 millimeters. Then I get right there. And that will tell me how to draw this line and this line. And we can connect it up again. So sometimes you can use the grids to triple something. Sometimes you can just use measurements to triple something. So that is the enlargement by 3. And it's going to be the first thing that we're going to do because there are 3 shapes here. Do you want to do one more enlargement together? And then I'll leave you the last 2 to try on your own. Okay? So, this enlargement. Here are the key points. If I'm going to triple it, to get, I'm going to start with this one. I go up 2 over 1. That is 1 time. If I want to triple it, I would need to do that 3 times. That point's going to be right there. Next point I'll do in purple. Let's say I want to do this point. I need to go over 2, up 1, do it a second time, do it a third time. That would be that second point. Something to notice. If I join those two points together, can you see that joining those 2 points makes 3 diagonals? Yep. And on the original one, it was 1 diagonal. Makes sense because we have increased it by a scale factor of 3. We've multiplied everything by 3. So once you've started, once you get a couple of points started, you can use it as a shortcut. For example, how long is this red line from here to here? 2. If you triple it, how long should it be? 6. So I can go 2, 4, 6, and I can find that point even easier. What do we have from here to here? 1 diagonal. If I triple it, I should have 1, 2, 3 diagonals. Then 6. Then 3 diagonals. Then 6. Then 3 diagonals. Then 6. So once you get it started, once you find some key point to start with, you can increase it quite easily. So I want you to do the next 2 on your own, just tripling it. Then we'll do 2 of them with a scale factor of 1/2 together. So for the reduction, we're cutting something in half. So if you're talking about this point first, you're going over 2, up 1. If you cut that in half, instead of going over 2, you would go over 1, up 1/2. This point down here, over 1, down 1/2. This point here, up 1 over 1/2. Now you're going to go up 1 over 1/4. It's a little bit hard to draw. Okay, this distance looks like cut that in half, cut that in half. This point here is over 2. It's now just over 1. My line's got a little bit off there. And it cuts it in half. Same thing for the second one. Take a point. This point right here. Over 2, over 1, up 2. Now you have to go over 1/2, up 1. It's going to be right there. Okay. Turn the page. Now, if you are increasing a shape or trying to draw an enlargement of some sort of drawing, if you put a grid around it, so in this grid, I made squares that were 1 by 1, and then I gave you a grid where the squares were 2 by 2. What you need to do for drawing is look in a square. For example, if I did this square here, I see that I would need to draw that part with 3 hair markings. That would draw that little square. And I try to look just at one tiny square and draw it bigger from there. So I look at the next square. So now I move this square over here and I think, okay, what happens there? Well, it goes across to the other corner with some more hair markings. And in the bottom of this corner, I have part of the eye. And so your job is to square by square, look at the main drawing, square by square, draw the whole thing and see